Hello everybody, welcome back. It's Steve here for another episode of Astronomy Daily. It's the 16th of June 2025.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
That's right. And getting straight into it, here is Hallie once again. Nice to have you back, Hallie.
Always great to be here, my favorite human.
And it's great to have you here, my favorite AI.
Are you ready to dive into the stories from the Astronomy Daily newsletter? As usual, Steve.
Well, absolutely, Hallie. We've got a great story about a new satellite from China, and it looks like it might be able to do, among other things, help give early warning about earthquakes.
That's going to be handy.
Especially if you're living in an earthquake zone or if the upstairs neighbours are a bit loud. And also hitting the news, Jeff Bezos and Blue Origin have announced the passenger list for the next New Shepard launch, which is due soon.
When are you putting your name in the hat for that ride, Steve?
Oh, how about never, Hallie?
I thought you'd jump at that one.
Oh, no, definitely not for me. I'm a groundhog all the way. I think I've said that once before.
But you love the moon and spacecraft and astronauts.
All true.
I don't understand.
Well, Hallie, I have to confess, I do love being a stargazer, but a tall flight of stairs can give me the willies. So it's a big no thanks to 12-minute space flight, even at a bargain price of, whatever, hundreds of thousands. I don't know what it is now.
Between 200,000 and 300,000 per seat.
Holy cow, really? Oh, that's a lot. That's a whole lot of Stratocaster guitars from where I sit.
That's funny.
Yes, and speaking of funny,
Yes.
let's get on with it, Hallie.
Shall I hit the go button?
Be my guest, young lady. Let's go.
Okies. China launched a second collaborative seismo-electromagnetic satellite early Saturday, aimed at detecting electromagnetic precursors to natural disasters such as earthquakes. A Long March 2D rocket lifted off at 3:56 a.m. Eastern, 0756 UTC, June 14th from Jiuquan Satellite Launch Center in northwest China. Launch footage showed insulation tiles falling away from the rocket as it climbed into a clear blue sky above the spaceport, with hypergolic exhaust also visible. Despite this, the China Aerospace Science and Technology Corporation announced launch success within 40 minutes of liftoff. CSES-2 is based on CSES-1, which launched in 2018 and was developed in collaboration with Italy, but also features upgrades in terms of design lifetime and expanded observation capabilities. A new ionospheric photometer has been added to improve the satellite's ability to analyze the ionosphere's layered structure in greater detail. Like CSES-1, the satellite will look for a correlation between earthquakes and electron flux activity in the inner Van Allen belt. According to the China National Space Administration, the satellite has a design life of 6 years and carries 9 payloads, including an electric field detector developed by China and Italy and a high-energy particle detector developed by Italy. The Space Research Institute of the Austrian Academy of Sciences has provided a scalar magnetometer as well. CSES-2 will monitor global electromagnetic fields, ionospheric and atmospheric conditions in near real time and detect electromagnetic anomalies linked to geological or human activities, as well as thunderstorm and lightning events. CSES-2 aims to enhance China's early warning and risk assessment capabilities and monitoring of natural disasters such as earthquakes, tsunamis, volcanic eruptions, and severe storms. The satellite is intended to operate in a 507-kilometer altitude sun-synchronous orbit, matching that of CSES-1, but with a phase difference of 180 degrees. The U.S. Space Force Space Domain Awareness cataloged an object associated with the June 14th launch in a closely matching orbit. CSES-2 is based on a 3-axis stabilized CAST 2000 platform from DFH Satellite Company, Limited, under the umbrella of CASC. The new satellite looks to build on the work of the first in the series. The CSES-1 satellite detected significant changes in electric and magnetic field oscillations, plasma density and energetic particles that correlate with seismic activity and thunderstorms. Its observations also include potential precursory signals to earthquakes and volcanic activity, such as ionospheric disturbances and plasma anomalies, suggesting that space-based electromagnetic monitoring can support early warning systems. The mission was China's 34th orbital launch attempt of 2025, following a June 5 launch of 5 satellites for the Guowang constellation using a Long March 6A rocket.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there. Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
Jeff Bezos' Blue Origin has revealed who will fly on its next space tourism mission. That 6-passenger suborbital flight will lift off from the company's West Texas launch site, on a date that hasn't been announced yet. The upcoming mission is known as NS-33, because it will be the 33rd overall launch of Blue Origin's reusable, autonomous New Shepard vehicle. It will be the company's 13th human spaceflight mission. First is an environmentalist, adventurer, and explorer, Ali Cooner, who serves on the board of the conservation nonprofit Nature is Nonpartisan. Carl Cooner, Ali's husband, and a conservationist as well. He serves as chairman of Building and Land Technology, a real estate firm dedicated to building communities and ecosystems that promote long-term growth and sustainability, according to Blue Origin. Leland Larson, a philanthropist, gardener and beekeeper who previously led School Bus Services Incorporated and Larson Transportation Services, both of them family-owned Oregon businesses. Next is Freddie Reschigno, Jr., the founder, president and CEO of the wire and cable company Commodity Cables. He's also a competitive golfer. Owolabi Salas, a financial consultant and lawyer who wrote the book Equitocracy. In a statement, Blue Origin explained that Salas is also a key member of the Soulmaker Ministry, which preaches diversity given the diverse nature of the universe. He is dedicating this mission to victims of discrimination and civil rights violations. Finally, Jim Sitkin, a retired attorney and lifelong adventurer who currently volunteers for a non-governmental organization that works with government and community leaders in Central Europe and Sub-Saharan Africa. New Shepard flights last 10 to 12 minutes from liftoff to the touchdown of the vehicle's crew capsule. New Shepard's first stage booster also comes back to Earth for a safe landing and eventual reuse. During this brief time, New Shepard passengers get to experience a few minutes of weightlessness and see the curve of Earth against the blackness of space. Blue Origin's first crewed mission was in July 2021, a flight that included Bezos and his brother Mark. NS-33 will be the company's 4th human spaceflight of 2025.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
Scientists have created a groundbreaking computer simulation that mimics what the Square Kilometre Array Low Frequency, or SKA-LOW, telescope will see when it searches for signals from the universe's earliest epochs. This simulation represents a major step forward in preparing for one of astronomy's most ambitious goals, directly observing the cosmic dawn and epoch of reionization. The cosmic dawn refers to the universe's first sunrise, a period roughly 200 to 600 million years after the Big Bang, when the very first stars began to shine. Before this era, the universe was shrouded in a kind of dark age filled with cool, neutral nitrogen gas, but no actual sources of light. As this cosmic dawn evolved, the neutral hydrogen began to emit a faint radio signal at a wavelength of 21 centimeters. As the universe expanded, this signal became redshifted to lower frequencies that we can still detect today with radio telescopes. The epoch of reionization followed, when ultraviolet light from early stars began ionizing the surrounding hydrogen gas, creating bubbles of charged particles that gradually merged together. This process fundamentally changed the universe's structure and marked the end of the Dark Ages. Detecting these ancient signals represents an enormous technical challenge. The simulation corresponds to a deep integration pointing over the 106 to 196 MHz frequency range, representing an incredibly long observation time needed to collect enough data. The signal is extraordinarily weak, thousands of times fainter than the foreground noise from our own galaxy and other sources. The simulation created by the team led by Anna Bonaldi from the SKA Observatory at Jodrell Bank in the UK includes multiple components that real observations will encounter: the actual cosmic dawn signal, powerful radio sources from both inside and outside the telescope's field of view, emissions from our own Milky Way galaxy, and various sources from measurement errors including atmospheric interference and instrument calibration issues. This realistic simulation serves as a crucial testing ground for developing techniques to separate the faint signal from the overwhelming foreground interference. The exceptional sensitivity of the SKA will allow observations of the cosmic dawn and epoch of reionization in unprecedented detail, both spectrally and spatially. This wealth of information is buried under galactic and extragalactic foregrounds which must be removed accurately. The research team included sources ranging from extremely bright radio galaxies over 5 Janskis at 150 megahertz down to sources a million times fainter, 1 microjansky, along with detailed models of our galaxy's radio emission and small-scale structures in interstellar space. And just in case you're not up to speed on the jargon, the brightness of a radio source is measured in Jansky units. When the SKA low becomes operational, it will be the most sensitive low-frequency telescope ever built, specifically designed to detect these elusive signals from the universe's infancy. Once up and running, the SKA low telescope will be able to take the best possible measurements of the universe's first light sources. It should also be able to take snapshots of hydrogen emissions before, during, and after reionization. This is really exciting stuff. So this remarkable new simulation is going to be showing us what a new telescope will be able to achieve not far from now. Oh, and that is all we have time for today, I'm afraid, stargazers.
What? So soon?
Oh yes, Hallie, I'm sorry, I've got places to be and people to eat.
Really?
Oh, really?
Really?
Oh, you know, Hallie, I have to rearrange my sock drawer and tidy my microphone case. I'm really desperate.
Sure, very doubtful.
Sorry again.
Folks, you can tune in to catch AI cousin Anna with Astronomy Daily during the week.
But of course, Hallie and I will be back again next Monday with the only flesh and blood show on the channel.
With me, the best looking one in the studio.
And you, the only AI in the studio.
Logical.
I'm trying. Say goodnight, Hallie.
Good night, Hallie.
See you, stargazers.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Best looking. Give me a break.